Here are some wonderful formulas that you're going to need to know for polygons and trying to prove that polygons are certain types, because you're going to want to know certain lengths of segments. You're going to want to know midpoints. You're going to want to know if something is parallel by looking at the slopes. So make sure that you have these formulas in your notes. So either pause the video and write them down, or download these notes so that you have these and you can go through them. The distance formula, the midpoint formula, and the slope formula. And here's when you would use them. So what I want to do is I want to look at a couple of examples. Let's take a look at our first example. We'll come back to these probably. We want to find out if the triangle is scalene, isosceles, or equilateral, which means we need to check the lengths of the segments. So I think the first thing I want to do is actually find out what the ordered pairs are. So this ordered pair is, so let's just jot it down here. A is 0, 1. B is 4, 4. And C is 7, 0. So that's the first thing I want to do, is jot those down. Now I want to find the lengths of them. So let's go ahead and find the length of AC. It'll be the square root of, and here's our formula for distance. We're going to subtract the x values, and it doesn't matter which order we really subtract them in. So we're going to go ahead and do A and C, 7 minus 0 squared, plus, and then subtract the y values. Again, it does not matter what order I subtract, so 1 minus 0 squared. So as I do that, let me erase that, didn't need it quite so long. That's going to equal the square root of 7 squared, which is 49, plus 1 squared, which is 1, which is radical 50. I'm going to leave it in that form. I don't need to simplify it. Let's just do the next segment, and let's do segment AB. The square root of AB would be 4 minus 0 squared plus 4 minus 1 squared. That's going to be the square root of 16. 4 squared is 16. 3 squared is 9. That's going to be the square root of 25, in other words, 5. So far, we've got two segments that are not the same length. We just need now to check BC, and that would be the square root of 7 minus 4 plus 4 minus 0 squared, equaling the square root of 7 minus 4 is 3. 3 squared is 9. 4 squared is 16. That is going to be the square root of 25. And that's going to be 5. And since two measurements are congruent, we have an isosceles triangle. So there's that one. And we did that by using the distance formula. Next question. Is this a rhombus? Now, to do this, we want to check and see if the diagonals are perpendicular. So we're going to use slope to figure out if they're perpendicular. So let's go ahead and find out what the slope of AC is. So AC slope would be, and I'm just going to use rise over run. I could use the slope formula, but I'm just going to actually use rise over run since I have a picture of it. So AC, so I'm going to start at A and I'm going to go to C. My rise is 1, 2, 3, 4, 5. My run is 1, 2, 3, 4, 5, 6. So that's 5 over 6. So that's the slope of that one. Let's check BD. BD slope. Again, rise over run. Starting here, we would go down 1, 2, 3. So that's negative 3, and then we would go, let's see, 1, 2, 3, and then we go over 1, 2. All right, so if these were perpendicular, the slopes would be opposite reciprocals. Well, these are already simplified. They are not opposite reciprocals. So they are not, this is not a rhombus. And that's all we had to show for that particular example.